I don't want to spend too much time on this because it is Form 2 work. Once you've written it, now we can look. Okay, they say you can see that you have 2 of those molecules, 2 of those things, so that, and then you've got 3 of those things. So now again, this could be my compound iron. It's 1 atom with 3. So it could be this one. So remember, multiple choice you must do by process of elimination. Could be this one, could be this one, and could be that one. So the SO4 is the rubbish. There's always one that's clearly nonsense. And this time, that was the SO4, because this iron only has 1 atom with 3. So it could be either one of those. If I have 2 of this one, I must have 3 of that. So this one tells us that Na 1, 1. So we know that one is also wrong. This one is 1, 1. So that one is also wrong. So by default, the answer was B. Who got that right in the first place? Nice, guys. Okay, so the answer is B. All right, for the next question. This is, for some reason, a very important question. This question shows a hydrogen bond. But it's testing that you know what a hydrogen bond is. This is why your definitions are important. Who has learned their definitions yet? What is a hydrogen bond?
No, a hydrogen bond is a bond between hydrogen and either nitrogen, oxygen, or phosphorus.
Good. So you need to look for a hydrogen going to, NOF, yeah, fluorine. So NO or F. So hydrogen goes to O here. Could it be that? Possibly. Hydrogen goes to O here. Could it be that?
Yes.
Okay. Hydrogen goes to hydrogen here. Could it be that?
No.
Clearly the rubbish. Hydrogen goes to oxygen here. Could it be that? Okay, but there can't be 3 answers. So now you need to start limiting what you are doing. The bond must be between the hydrogen of one molecule and the oxygen of another molecule. How many molecules do I have here? Only one. Can there be, remember, a hydrogen bond is a hydrogen bond intermolecular force. It must be between 2 molecules. Do I have 2 molecules there? No. So again, clearly this one is rubbish. Because there's only 1 molecule. So that's inside the molecule. What do I call that?
Intra.
Thank you. Intra. Well done. Okay, so it's inside the molecule. But now we need to decide. So these 2, there's always 2 that's going to confuse you. So it's these 2 this time. So this is between a hydrogen and oxygen, and this is between a hydrogen and oxygen. But why is that first one not right? Why is A not right?
Because oxygen's valence shell is full.
If you look at both of them, this oxygen, this one here is fine. These 2 look exactly the same. There's a problem with this molecule. And so look there where that hydrogen is going. That hydrogen is going to a carbon. This hydrogen is going to an oxygen. So the bond must be between a hydrogen and an oxygen, but the other hydrogen must also be bonding to an NO or an F. So this is a bit of a higher order question, but look out for these. Multiple choice questions set traps for you. So a hydrogen bond is between an H and a NOF, not between H and a carbon. So this one was not right. So the answer is D. Look out for this. There might be a similar question in your tests on coming up. Might. Okay, everyone clear on this one? So if it's hydrogen bonding, it's between the hydrogen of one molecule that is bonded to an NO or F and the NO left of another molecule. All right, yeah. Can you see that now just naming, which is form 2 work, is going to give you basically 8 marks. So please don't get these wrong. Zinc dichromate. You need to know that this is Zn 2 plus. Dichromate is Cr2O7. But now, what is the charge on Cr2O7? 2 minus. So this is plus 2 minus 2. They cancel each other, so I just need one of each. Done. The next one is potassium, hydrogen, carbonate. So you just write them down first. I hope this is how you're doing it. Just go and write them down first. Potassium is K. Write the charge here, plus. Because we don't want to see pluses and minuses in a formula. Remember, no pluses and minuses. Some of you lost a lot of marks for that in the previous test. Hydrogen is just an H, but H is also, is it plus or minus? Plus. So potassium, hydrogen, and then what is carbonate? CO3, and CO3 is 2 minus. Does that give me 0? Plus 1, minus 2. Does that give me 0? If it gives you 0, you leave it the way it is. Please. Don't fiddle with something that's perfect. Okay, then we've got lead 4. When it's a transition metal, the 4 always talks about the thing in front of it. What's the symbol for lead? B. What's the charge then if it tells you that Roman numeral? Plus 4. The first one is always positive. What is carbonate? CO3. And it's 2 minus. Now let's look at our charges. It's plus 4 minus 2. Does that give me 0? No, what must I do? I need to make 2 of these. So that means my carbonate, I need 2 of. You happy with that? Perfect. Sulfur dioxide. So is this an ionic or a covalent substance? Covalent. So here we look at the name. So sulfur is just S. And dioxide means? So it's just SO2. If it's a covalent bond, are you going to put pluses or minuses? Okay, so whenever it's covalent, please remember there's no ions. So you cannot put a plus and a minus there. There are no ions. Okay, names of the following. N2O2. Okay, they will mark it right if you just say nitrogen dioxide. But because you guys are now getting used to the names, dinitrogen dioxide. Okay, but then the next one is the more important one. SN is what? Okay, so please just write the name first, tin. Then put your finger on tin on your periodic table, because we will give you a periodic table. So put your finger on that periodic table at tin and then decide, does it have a charge? It does have a charge, but do you know what its charge is? Yes. What? Okay. Guys, in this case it's going to be 4, but does it have to be 4? Tin doesn't have to be 4. Tin is actually transition. Please be careful. If we look at our periodic table, where was this given? I think it's at the end of the test. If you look at your periodic table, remember when you're deciding about the transition, if it's a transition metal or not, you have to put the aluminium roof on. So so if you look at your, it's put a roof on aluminium there. Okay, these things, aluminium is the only one that's still group 3. These things here are metals. These are always metals. You always put a roof on aluminium. Okay, that's the in thing to do. And then you go down in steps. These are the metalloids here. And these are all transition metals. So tin and lead, even though it looks as if it's in group 4, is not in group 4, they transition. These are all transition metals. So you cannot treat tin as if it's a transition metal. And if we go back to the question, then as soon as you know it's a transition metal, you must realize that it needs a bracket. So when you put your finger on it in the periodic table and you see it's transition, it needs a bracket, otherwise you're not going to get that mark. But what is NO3? Nitrate. Now you need to figure out what that bracket must be. So you know that NO3 is -1, but there are 4 of them. So 4 minus 1 gives me -4. So what must my pluses be?
4.
+4. So that means what must I put in my Roman numeral?
10.
Will you be able to do this if you get one on? Okay, this is the only way we can make it a little bit harder. It's by giving you the transition metal to get the, we call this stock notation. So if the question says use stock notation, this is what you need to do. Put the Roman numerals in there. Oops, sorry. All right, now, they tell you in this question that it is an ionic substance. So please, if you read ionic substance, what are you never allowed to say for ionic substances? It is between nonmetals and nonmetals, yes, but please don't ever talk about IMFs. Ionic substances do not have IMFs, because do they ever form molecules? No. So please, when you read ionic, just tell yourself quickly, I am not allowed to say IMFs ever. No, never allowed to say IMFs. So ionic substances, no London, no hydrogen bonding, no dipole. Because if you don't tell yourself now, you might just fall into that trap. Then they say, the diagrams show the lattice of an ionic substance. Explain what is meant by an ionic bond. This is a definition. So what an ionic bond is a?
Bond between metal and non-metal where there's a transfer of electrons from the metal making it a cation to the non-metal making it an anion.
You still only get one more. Well, how can you make this way easier for yourself? Go to your notes and just literally learn the definition. It says there, if you look at your notes, it says there the SAG's definition. Where is it? I think I have it open still from earlier. It says it's a transfer of electrons from one atom to another and the subsequent electrostatic attraction between the cation and the anion. Okay, so please go and learn your definitions. Guys, it's 2 free marks, but it's only free if you know it. So you know the definition, but just because you left out the force, you don't want that happening. Okay, so that's our definition. Then, the next question says, refer to the forces between the particles to explain why sodium chloride is able to conduct electricity, very important, in the liquid phase and not in the solid phase. Very important. So you need to explain what an electrolyte is, basically. So again, if you knew your definitions, you would be perfectly fine. Why can it not conduct like this? I think I did this with my class 10 times.
Because the electrons, because it's like together the ions are like together, so there's a higher electrostatic force. So we want to have like more energy to like overcome.
That's if you want to melt them, yes, that would be the perfect answer. This question is asking about electrons conducting electricity. Now, okay, let's go back.
Oh, the ions.
When you want electricity, you need two things. You need a charge, and what must that charge be able to do?
Attract an opposite.
Before that, what must they be able to do?
Move.
Move. Guys, use plain simple English. You need a charge, and that charge must be able to move. So in the solid form, can they move? No, what are they that I'm talking about? What are the particles? If you say electrons, we stop reading and we give you 0. You make our lives very easy. Where are the electrons, guys? What are these things? We were told what they are. What are they? Ions, please. If you use the wrong word in chemistry, you floor yourself. Okay, it's an ion. So you need to say, in the solid form, ions cannot move. Why not? Due to many, please use the word many, strong electrostatic forces. This is super important, guys. But then there's two ways. We actually did 2 ways in which you can make them conduct. Say again?
Dissolving.
You can dissolve them. If you dissolve them, they become aqueous. Or you can melt, and then they become a liquid. So now they say, why in the liquid phase can they now conduct?
And because in the ions are moving.
Ions are free to move to conduct electricity. Sorry, I'm writing very badly.
Does that mean they delocalize?
No. Can an ion be delocalized? What are the things that are delocalized? See, that's where the wording becomes easy, but important. If you say electron when you're supposed to say ion, or you say ion when you're supposed to say electron, look what I just wrote. Okay, so guys, very important. Do not speak electron here. What are you going to speak about in an ionic bond? Ions, please, ions only. Talk about ions, not electrons. So the only reason why they conduct is because the ions are free to move. Electrons moved a long time ago when this bond formed in the first place. All right, next question. So this question now, they're giving you 2 molecules. They're telling you that it's graphite and diamond. They call it macromolecules. What's the other name we gave to it? They call it macromolecules in your book as well, but they use a simple word that we used.
Lattice.
Lattice is for ionic substances. Giant covalent, guys. Giant covalent. So you already know that they are sharing electrons. So am I allowed to speak ions now? So will you ever use the word ion? As soon as you know it's covalent, are you allowed to use the word ion in this question? Never ever. Please, so tell yourself that when you start with the question, because now you know I'm not going to fall in that trap. I'm going to not talk about an ion. There are no ions. They are sharing electrons. Okay, then it says what is meant by an allotrope, still another definition. It is just a different form. Okay, I'm not allowed to say that, but yeah. I didn't say anything. Learn it. Then, name the specific type of bonding that occurs within the graphite and diamond molecules. What type of bonding? Yes, remember I want 3 words. Very well done. So it's not just a covalent bond, because a covalent bond will only give you 1 mark. So yes, it's a covalent bond. Why does he say that it's non-polar?
There's no difference in electron.
You are getting confused with bonds and IMFs.
Symmetrical.
You are still talking about molecules, guys. Guys, non-polar molecule is about the whole molecule. Mazuba, help me. Is it distribution? Wrong word. Difference in electronegativity is what? 0. So what? It's equal, not distribution, equal sharing of electrons. Please, when you look at the bond, you don't look at the symmetry, you don't look at the distribution of the electrons in the overall, you just look at 2. Remember, when I started this chapter, I said to you, when you see bond, how many atoms at a time do you look at? Only 2 atoms at a time, and you look at the difference in electronegativity. That is carbon, that is carbon. Is there a difference in electronegativity? No. Okay, please, please, please. Then the question says, why is graphite able to conduct electricity but diamond is not? What are you not allowed to use when you give me this answer? So what are you going to say?
I said graphite only makes 3 bonds between the carbons. Therefore, there will be an electron that moves between the layers. So there's an overall negative charge allowing it to conduct electricity. So, and then the diamond makes 4 bonds, so there will be no lone pairs or electron.
Okay, it's a lot of stuff to write for 2 marks, but you will get full marks for that answer. Well, how can we say it in plain, simple English? What do we need for electricity? A charge, and the charge must be? Moving, free to move. So graphite has, what is the charge? Stand up and sit down again. What is the charge that graphite has? What is the particle with the charge? You guys have...
Electron.
I heard a swear word.
An electron.
Thank you. Electron. Someone said iron. That is definitely a swear word when we're talking about a covalent substance. Graphite has electrons. Free to move and conduct electricity. And diamond has no free charges or charged particles. Done. So yes, you spoke in detail about why that electron is free. So, but did the question ask you to explain that? So be careful of running out of time in an exam. But your answer was still perfect. But that first bit, they'll just scan through and wait and look out for electron moving. For graphite, and electron not moving for diamond. Okay, guys, this electricity thing, definitely very important. Okay, and you will definitely get this as well. 100%. This will be in your test. Use Lewis diagram to show the bonds. What is your first job? Before that.
Draw the symbols.
Before that.
Get a pencil.
That's a good one. Get a pencil out. Once you have a pencil, what are you going to decide about the substance?
Which one goes in the...
Before that. Before that. What type of bond is it? Guys, they say draw the bond. So now, how are you going to know if you're going to share their electrons or if you're going to draw arrows for a transfer of electrons if you don't know what bond it is? So you first have to decide what bond it is. This is calcium and bromine. Ca and Br. Is that ionic, covalent, or metallic? Where is Ca?
Ionic.
It's a metal, guys. Thank you. It's ionic. This one Ionic, metallic, or covalent? Alright, now if you have ionic, guys, remember ionic needs arrows. Covalent needs sharing. Because this is a transfer of electrons and this is a sharing of electrons. And if your diagram doesn't show that, you're not going to get full marks, Mazuba. Metallic is just the delocalized, no. They will not ask you that. Alright, so now you are, for the ionic one, you just draw them separately. Like you said, that is your next first step. So you're going to draw calcium with its electrons, and you're going to draw Br with its electrons. But there are two of them. So actually the symbol helped you. So calcium has how many electrons? 1, 2. Please use a different symbol or a different color or a highlighter for the other one. So the Br has how many? 2, 3, 4, 5, 6, 7. And this Br also has 1, 2, 3, 4, 5, 6, 7. Now, how do you show me? Well, remember, you want to make it easy for me to give you a mark. How do you show me that it's a transfer of electrons? Yes.
I wanted to ask, so we don't have to show that the electrons cancel the opposite sides?
Say again?
For calcium.
You don't have to? So, put it there and there. If you did, it doesn't matter. They wouldn't take a mark off. How do I show that it's a transfer, guys? Ionic needs an arrow. So you're going to show this electron is physically going to move there. And this electron is physically going to move there. And then you need to show the ions that form. So you need to show that this forms a Ca that doesn't have any electrons anymore. So Ca is just going to be like that. But it's going to have a 2+ charge. And with the Ca, how many of these do I have? 2. So you put a big 2 because I have 2 of the whole ion. And you put a square bracket. And you draw it exactly as it used to be. It had its own 7 electrons. But then in that place where it gained a new electron, you show that it's that electron that it took. So use the same symbol that you used for the calcium, because it's that round electron from calcium that now lives with the Br. And each of these Br has a charge. What is their charge going to be? There are 2 of them, but their charge will never be 2-. They are in group 7. What will something in group 7 always be? -1. So just a minus. All right, moving on. Guys, covalent is sharing. Guys, we need to finish this test. Covalent is sharing. So now you can draw your center molecule. So you can draw the one that there's the least of. So you can do your P. How many electrons for P? 1, 2, 3, 4, 5. And then you know hydrogen is going to share there. And it's going to share there. And it's going to share there. Happy with that? Okay, please tell me quickly. The bonds here, are they polar or non-polar? Bond. You guys are just guessing. How do you know whether a bond is polar? So you are all looking me in the face and tell me that it's polar, but you haven't even checked your periodic table. Thank you. find them on your periodic table. If you see bond, you're looking at 2 atoms at a time. Go and find a P and tell me the electronegativity.
2.1.
Find an H and tell me the electronegativity.
2.1.
2.1. Is there a difference in electronegativity? So it's an equal sharing of electrons. It's not polar bond, guys. Don't assume if it's a different atom. So these are actually non-polar bonds. But if I look at the whole molecule, what about the molecule? Is it a polar molecule or a non-polar molecule? It is a polar molecule. Why? Now you can all use all those words you've been using. Asymmetrical, lone electron pair, uneven distribution of electrons. All of those things, now you can use it. Be careful, you're going to fall in a trap on Thursday. If it's bond, what do we look at? Of 2 atoms at a time. If it's a molecule, then you look at the whole thing. Please, guys, if you're unsure of this, I have loaded the summary of bonding and IMF on your Google Classrooms. So go and look at that. Okay, I know some of you need to go, so if you do need to go, just quietly leave. I'm going to carry on though, because some people would like to see the rest of it, and the rest of you can watch the video. So if you need to go, just quietly leave. Okay, there is a question like this in your test as well, where we're giving you a bunch of substances and we ask you questions about it. So this was a very good test to choose, whoever did that. Okay, now you are distracting, so now you must leave quickly. Do you have to go?
That's fine. He doesn't have, he wants to go to gym.
Jim will be there after. All right, now, guys, look at the substances. The first question, so when you get a substance like a question like this, please go and tell yourself first which ones are ionic and take them out. Because you can, if it's ionic, what are you never allowed to talk about?
Electrons.
Ionic, you're not allowed to talk about electrons, and you're not allowed to talk about IMFs. Please remember that. So if I find the ionic ones first, this one is ionic because it's a compound ion and another ion. That's ionic. I think that's our only one. This is a metal, so you can mark the metal as well. The others are all, and this is a noble gas. Now remember, noble gas has London forces between the atoms, not the molecules. Then if it's symmetrical, you can even go a little bit further and go and find all the ones that are symmetrical. So you know already by now, CH4 is symmetrical, mark them as symmetrical. I2 is symmetrical, mark it as a symmetrical. Because as soon as it's symmetrical, what IMF do I have? London IMF, noble gas, London IMF. So help yourself like that. Okay, then. They want an element. An element. Guys, this is very important. An element. So can it have more than one symbol in there? One symbol only. So if I look at an element, there are 3. This is an element, this is an element, and this is the element. What are the others called?
Molecules.
Molecules or compounds. Yes, compounds. So look out for those words tomorrow. So molecules or compounds. No? Thursday, sorry, not tomorrow. Okay, so we're looking for an element with London IMFs. So it could be iodine. But is iodine and then there's a word in bold for a reason. They say, so it could be iodine or it could be Kr. But because they say between its atoms, which one is eliminated?
Iodine.
So it must be Kr because it's between atoms. Can you see how careful you must read in a chemistry exam? This is why I say English is very important for science.
Is it only noble gases that have London?
between atoms here. Then they want a substance with a hydrogen bond between molecules. Where's one with a hydrogen bond, guys? NH3. It's the only one because it's hydrogen with NO or F. So this one was pretty easy. Non-linear molecule. Linear means straight line. So two atoms will always be in a line. So if they say non-linear, it cancels everything that only has two atoms. And it cancels the noble gas, and it cancels the ionic, and it cancels the metal. So we only left with those two. So they say non-linear molecule with polar covalent bonds. If they ask me about a bond, what do I look at? Difference in electronegativity. So it could be NH3 or CH4. Which one is it? Or is it both? NH3 because N and H is different, but it could also be CH3. They're also different. So, yeah.
So CH4.
Oh, sorry, it's CH4. Yeah. So it's going to be it could be NH3 or CH4 because neither one of them are linear.
So do you say CH4 because you already said NH3?
They said select one. So it could have been either one, it doesn't matter. Yeah. But they didn't say that you're only allowed to use them once. You can use them more than once. So we marked both right. Alright, then a compound with non-polar molecules. You already labeled them. So it could be I2 or CH4. Which one is it? Why not I2? Because they said compound. So it's not I2, it's going to be CH4. And then substance that can conduct electricity when it's a solid and a liquid.
Metal.
The metal, so it's PT. Can you see that you helped yourself? Please can someone tell me, why does a metal conduct electricity? Yes.
Because of the delocalized electrons.
Okay, you get one more.
They move freely, man. Therefore, there's a free moving charge, which enables conduction.
Okay, so now you are using these words. Great. So you're going to say there are delocalized electrons which are free to. We're going to look for that word. It's a simple word. Just use it. There are delocalized electrons which are free to move and conduct electricity. Perfect.
Ma'am, with the metallic bond, what bonds with what? Does the metal just bond with itself? Or?
No, it's the electrons so the force is between the positive nucleus and the delocalized electrons.
So what's happening? Is it just like
Sticking together. That's why you can bend them. Because they can slide over each other like that. So that is when you do a metallic bond, you just have the plus, plus, plus. But what happens is, remember, a metal is very dense. So there's my nucleus, but then these outside energy levels are overlapping. So these electrons in the outside energy level, when they move around, they can move from the one to the other because they're not really sure, am I belonging to this positive or that positive? Because they are so close together. So those electrons, the valence electrons, are the delocalized electrons that can move freely. So it's the
same for iron ores.
No, for an ion, it's a positive particle next to a negative particle. And that, iron ore. Yeah, that's just iron.
Okay.
So it's just the metal, yeah. Ionic substance, though, is positive and negative. So here it's an electrostatic attraction between the ions. Here it's an attraction between the electrons and the positive kernels.
And then how do the alloys form?
That's just a mixture of metals.
Remember, Auntie just had another question.
Yes? Who's got another question?
Oh, it was me. I was
Yeah.
saying, what was I saying?
I don't know.
Electrostatic force.
Oh yes, both of them have electrostatic forces.
Okay, guys, this question is insanely important. You are going to get one of the three tomorrow, on Thursday. So this one is, explain the origin of the IMF in HCl. So firstly, you need to know what the IMF is in HCl. How do you decide? So you'll remember, go through the motions. Is it a symmetrical molecule or not? No. So you know already that you can immediately see that it's a non-polar molecule. If it's a non-polar molecule, you've got two choices. It's either dipole-dipole or hydrogen. Oh, I said guys, it's not non-polar.
It's polar.
It's polar. If you're in doubt, draw it. H has got one electron that it's sharing with Cl that has all those electrons. This is very much polar. Sorry, I just wrote down what you guys said. It's a polar molecule. If it's a polar molecule, I've got two choices, which is dipole-dipole or hydrogen bond IMF. But this is hydrogen, but is it a hydrogen bond IMF? Why not?
Because it's chlorine.
Not north.
No.
Good. So it is going to be dipole IMF. Now, have I answered the question? No, the question says the origin. How does it form? So the origin you need to know of this one, of hydrogen bond, and of IMF, and of London IMF. Make sure you can explain the origin of all three of them. Dipole-dipole, you have a polar molecule with a delta positive and a delta negative. The delta negative of the one molecule attracts the delta positive of the other molecule. There sits my dipole-dipole, IMF. Remember, you are always welcome to draw a diagram if you want to use your diagram to help you explain. Okay, so here's my one dipole, there's my other dipole. There we go.
There's a diagram fine in the test with the one words.
Sorry?
There's a diagram.
An annotated diagram could be fine.
Ma'am, would you be able to just draw it out like this to use all your marks?
It's 3 marks. So for saying that it's a dipole-dipole IMF, you get a mark. For showing the delta positives and the delta negatives, so that's your polar molecule. So you have to somehow show that it's a polar molecule. That's the other mark. And for showing where that the dipole-dipole IMF is between the delta negative of the one molecule and the delta positive of the other molecule. That's your other mark. Yes.
So, ma'am, we have to support this answer with the diagram.
You don't have to.
You don't have to. You can say that it's a dipole-dipole intermolecular force because there are there's a permanent polar molecule that has a delta positive side and a delta negative side. The delta positive side of the one molecule attracts the delta negative side of the other molecule, forming a dipole-dipole intermolecular force between them. Lots of words where the diagram shows exactly what I'm trying to say. Guys, so remember, origin of all three are important.
The third mark is you get for your diagram.
Yeah.
Explanation.
Wait, so London forces, ma'am.
London forces, yeah?
They're basically IMFs, right? But they exist in all of the bonds, but only in noble gases.
Only predominantly.
They are predominantly in noble gases.
And in symmetrical molecules,
So
non-polar ones. Okay, guys, so if the question does ask for London IMF, please know that you must be able to explain the origin of London as well. And if it asks for an H bond IMF, please know that you need to be able to explain